video, we are going to be looking at the sum and difference formulas for sine, cosine, and tangent. So here are the sum and difference formulas. We're going to do an example after this, but we have sine of alpha plus beta, alpha and beta being Greek letters denoting angles. So we have the sine of alpha plus beta equals sine of alpha cosine beta plus cosine alpha sine of beta. The second one is cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine of beta. Notice the difference between the two. Sine combines both sines and cosines in a product and then adds the sines and cosines in another product. Cosine, on the other hand, does cosine alpha cosine beta in a product, and then we subtract the sine and sine. So we keep the sines and cosines together in cosine. We mix them in sine. Tangent is going to be a rational expression with tan of alpha plus tan of beta divided by 1 minus tan of alpha tan of beta. Okay, the difference formulas for sine are just like the sum formula for sine, except in this case we subtract between the two. The difference formula for cosine is going to be exactly like the sum formula for cosine, except in this case we add between the two, and then tangent, you switch your subtraction and addition operations. All right, so let's jump in. You might want to take a moment, pause here to write these down, but we're going to jump into an example using these ideas. All right, so the value that we're going to try to look for is sine of 75 degrees. And we could use this for both sine, and we could use this for, for degrees. We could use them for, man, I forgot what they're, radicals. Man, that was like on the tip of my tongue there for a second. But in this case, we're going to use it for degrees. So I'm going to remember that I do know from the unit circle the values for sine of 30, sine of 45, and sine of 60. But I do not know the value for sine of 75. I'm going to see, can I combine these in any way to make the sine of 75? And I can. I could do 30 plus 45. All right, so here we have 30 plus 45. So this is going to be, we're adding two degrees. So this is going to be sine of 30 cosine of 45 plus cosine of 30 sine of 45. Well, from the unit circle, sine of 30 is 1/2. Cosine of 45 is the square root of 2 over 2. Cosine is 30 of the square root of 3 over 2. That was weird for me to say. Cosine of 30 is the square root of 3 over 2 times square root of 2 over 2 for sine of 45. So many sines and cosines. My brain is just not processing them fast enough. So we have the square root of 2 times 1, which is the square root of 2. 2 times 2 is 4. Square root of 3 times square root of 2 is the square root of 6 divided by 4. No way I could simplify the square root of 6 into a perfect square, so we're going to keep going on. Here we're pretty much at the end because we actually cannot combine the square root of 2 and the square root of 6. That does not make the square root of 8. Those stay separate. But what we can do is combine them over the same common denominator. Yes, I did realize I put 72 instead of 75. Let me change that. All right, so what I can do now is use a graphing device or use a calculator of any sorts that have a trigonometric button on it, and I could type in sine of 75 degrees, ensuring that my calculator is in degrees and not radians, and I get the decimal of approximately like 9.659-ish. And then I would put this in the calculator, see if I get roughly the same value of 9.659, and that would confirm that we did get the correct value. All right. So there are often more than one way to rewrite an angle measure as a sum or difference of a common reference angle. So this would probably be the best way for us to do something like this. All right, guys, so this is the end of this example. There are a couple of try-its that are interesting, so I would definitely recommend that you try the try-its, and I will catch you in the next video.